Functions review questions 13 and 14. Determine if the function represented by the values in each table is linear or nonlinear. To determine if it's linear or nonlinear, we have to examine the ratio of the change in y values to the change in x values. In other words, that's a fancy way of saying we have to find the slope between each point and see if the slopes are equivalent. If they are equivalent, then it will be linear. If they're not equivalent, it will be nonlinear. So we're going to do this. We're going to start by subtracting from the bottom up. So I'm going to take 36 minus 1 to get 35. 1 minus 0 to get 1. 0 minus 4 would be negative 4. 4 minus 25 would be negative 21. 6 minus 1 is 5. 1 minus 0 is 1. Now this is where you need to be careful. 0 minus negative 2. Minus a negative. You have to put the minus and the negative in your calculator if you're using a calculator. Or you could just remember that minus and negative would actually become positive. So this would be 0 plus 2, which is 2. Negative 2 minus negative 5 minus a negative would become positive again. So negative 2 plus 5 would be 3. Now we set up these ratios. So remember, it's always the difference in y value over the difference in x value. So the y values will go on top. So I've got negative 21 over 3, negative 4 over 2, 1 over 1, and 35 over 5. If you're not sure I got those numbers, they're across from one another. Negative 21 over 3, negative 4 over 2, 1 over 1, and 35 over 5. Okay, so now we divide these. Simplify. Negative 21 divided by 3 is negative 7. Negative 4 divided by 2 is negative 2. 1 divided by 1 is 1. And 35 divided by 5 is 7. Are these numbers equivalent? No, because they're not equivalent. And even if 3 out of the 4 were the same, just one different would make it nonlinear. Just one of them being different would make it nonlinear. So this is a nonlinear function. Number 14. Again, starting from the bottom. Be careful. Negative 7 minus negative 3 minus a negative becomes plus 3. So this would be negative 4. Negative 3 minus 3 would be negative 6. 3 minus 5, negative 2. 5 minus 15, negative 10. 5 minus 3 is 2. 3 minus 0 is 3. 0 minus negative 1 minus a negative becomes positive, so that would be positive 1. Negative 1 minus negative 6 minus negative 6 would be plus 6, so negative 1 plus 6 is 5. Now I set up these ratios, so negative 10 over 5, negative 2 over 1, negative 6 over 3, negative 4 over 2. Let's simplify these. Negative 10 divided by 5 is negative 2. Negative 2 divided by 1, negative 2. Negative 6 divided by 3, negative 2. Negative 4 divided by 2 is negative 2. These are all equivalent. They all are negative 2. Now, if one of them would be positive 2, that would not be all the same. So please be very careful of your signs. But because all of these are negative 2, that makes this a linear function. If you have any questions on problems 13 and 14, please let me know.